This is number 3 from the 2004 exam. So we have a particle moving along the y-axis, and we are given the velocity of that particle. And we are given the starting position at t equals 0. The particle is at y equals -1. So for part A, we need the acceleration at t equals 2. So what we're looking for is v prime at 2. And you can go straight to the calculator and get the derivative. And you should get this or this depending on whether you round or not. Now part B asks about the speed of the particle. So we know that acceleration at t equals 2 is negative. We need the velocity at t equals 2. Again, we use our calculator, and you should get -0.436. So what we notice here is that velocity is negative and acceleration is negative at t equals 2. So the speed is increasing because both are negative, because acceleration at 2 is negative and velocity at 2 is negative. Part C, we want to find the time at which the particle reaches the highest point. So we want to know when velocity is equal to 0. So that's going to happen when this function is equal to 0. We can solve this equation using the calculator, and you should get 0.443. Now we do have to justify our answer, and there are a couple ways of doing this. One way would be to look at the graph of v, and you'll notice that if you put this graph into your calculator, that at t equals 0.443, velocity is going to change from positive to negative. So you can write that out as your statement, explain that velocity changes from positive to negative at t equals 0.443, therefore we have a maximum at t equals 0.443. Or we can do the second derivative test and take a look at v prime being the second derivative of position. So v prime at 0.443 I'm just going to use my calculator and get that this is -0.455, which is negative. Therefore, the particle reaches its highest point at 0.443. And finally, we're up to part D. Find the position of the particle at time t equals 2. So the position, we know that the particle starts at -1. And then we just add the integral of velocity from 0 to 2. And that should be -0.1360 or -1.361. In the very last part, we are asked if the particle is moving toward or away from the origin at time t equals 2. Well, we know that the position is to the left of the origin at t equals 2. And we also know from our previous work that the velocity is negative at t equals 2. So the particle is at a negative position, and moving to the left in the negative direction. Therefore, the particle is moving away from the origin. Because, let's see, position is negative at t equals 2, and v of 2 is negative.